Greeting engineers, welcome to another episode of Code Boulevard. Here we are going to talk about observability and why we need that, what's the difference between observability and monitoring. In this episode, we are going to talk about monitoring, and after that we will discuss about observability, what's the difference between them, why we should use each of them, and we will check the components of observability, which is data collection and instrumentation. Then we will talk about visualization and dashboards, which tools we have and how we can use them. Then we will discuss about incident automation, how it's going to benefit our team. And after that, we will check the challenges and pitfalls of observability. And finally, we will talk about observability tools and how we can choose between them and how we can benchmark them in case we want to select some of them. All right, let's start with monitoring. First of all, let's have a definition for that. Monitoring actually involves the systematic collection of data about the system's health, performance, and other key metrics. It typically focuses on predefined indicators and thresholds. The primary goal of monitoring is to detect and alert on deviation from expected behavior, and it helps identify issues or potential problems in the system. And for example, we can monitor the CPU usage, memory usage, and any type of resources that we are using for hosting and tracking the response time of a web application and logging errors or exceptions in an application for later analysis. And in this picture, you can see we have a dashboard for logs, which shows the Kibana dashboard. Also, Grafana dashboard shows the resource usage that we have in our application. And generally, we can say monitoring is a subset of observability that involves keeping track of important events in an application. There are so many tools out there for monitoring your application, like Grafana dashboard, which shows your resources, how you are using, or in the other side, for checking events or logs in the application, you can use Kibana dashboard. We will get to that point and check all the monitoring tools that we have. The second point is observability. The definition of observability can be the measure of how well you can understand the internal state of a system based on its external outputs. Maybe definition is not that clear, but when we talk about observability, we are talking about a bigger picture. Means I want to understand how the system works. And mostly when we are talking about observability, we have a complex system, and the relation between services need to be monitored. So the purpose of observability providing insights into the system's internal working and facilitate debugging and troubleshooting, because when you have a complex system, it's not that easy just by checking some logs. So we need something else like observability tool that we are going to discuss about them. The example for observability can be instrumenting the code to capture detailed trace, logs, or events, or with the help of distributed tracing, it can follow the flow of a request. If you're having a microservice architecture, you should understand how your flow works. And for instance, if there is a delay in your response time, you can easily track down your request and see in which step we are facing the bottleneck. Maybe the authentication system doesn't respond properly or other system. So with the help of tracing system, distributed tracing, it makes it easier for us to track down the system structure and see how it behaves in a complex system. When we are talking about observability, it includes three main components. First is logs, which includes system and server logs, network system logs, and application logs. And the second one is metrics, monitoring CPU and memory usage, infrastructure metrics, and any other type of metrics that we need to observe the performance of the application. And the last one is traces, or the same distributed traces, and we can track the performance of microservices and relation between services. After we understand the definition of monitoring and observability, let's distinguish them based on the definition that we know. We can differentiate monitoring and observability based on several aspects. First can be focus. Monitoring emphasizes on predefined metrics, and in the other side, observability emphasizes on understanding the internal state. Means I have a complex system, so I need to understand how this big system works. Second aspect is purpose. Purpose of monitoring is detecting and alerting on deviation from norms. It means I know how the system works, so I can set some logs, some events, and in case of problem or any kind of debugging, I can check the logs. And observability facilitating deep understanding and debugging, because you are dealing with a big system, so it's not that easy by checking some logs to understand how it works. The next item is data collection. In monitoring, we collect specific metrics on logs. Maybe it can be by instrumenting the code or by monitoring the resource usage, but observability means capturing detailed traces, logs, and events. The next one is alerting. In monitoring, triggered by predefined threshold means I already know how my system is gonna work, and in case if there is a deviation, I can set some logs for that. But in the other side, observability tool or framework, they are smart enough to understand and detect any unexpected pattern, and based on that, we can send some alerts. Next one is use case. In monitoring, we are identifying and responding to known issues. But in the other side, in observability, we are exploring and diagnosing unknown issues. We can consider it as the same as detecting unexpected patterns with the help of observability framework. And the other is scope. Focuses on a subset of relevant metrics in monitoring. But in observability, we are talking about broader range of system aspects, and we are talking about the big picture and a lot of components in it. And the last one is tools. For monitoring, we have plenty of tools out there like Prometheus, and for observability, they are a bit more smarter than the monitoring, like ELK Stack, like Datadog, Dynatrace, etc. We will dig a bit more about the tools and how we can benchmark them and find a proper solution for our scenarios. In observability, we have data collection and instrumentation concept. These two actually are integral components on observability and providing means to gather information about internal working and performance of a software system. With the help of data collection, we can just collect different type of metrics from different part of the system, and with the help of instrumentation, we can produce some specific metrics based on our requirement and in order to monitor the performance of the application that we are using it. Now let's see how data collection works. The definition of data collection involves gathering relevant information and metrics from various components within a software system. And the purpose of data collection is to helping and monitoring, or in case we need to analyze the status and behavior of the system and see if it's working properly or not. Here I have an example of Prometheus server configuration. As you can see, there is a target here, shows an application already hosted on localhost 5000, and we need to scrape metrics from this target and store the metrics somewhere in order to monitor the performance of the application, and maybe we can show these metrics on a dashboard like Grafana. Now it's time to talk about instrumentation. The definition for that is whenever you need to gather some information or metrics from a specific part of your application during the runtime, instrumentation can help. And the purpose of instrumentation is providing a way to gather fine-grained insights into the behavior of the application and allowing for detailed analysis and troubleshooting. In this example, as you can see, I have an application. It doesn't matter in which language you are using because there are so many frameworks out there you can use based on your language that you are using. But here in this example, I'm sending some metrics that shows the number of requests that I'm receiving in my application. It means I want to gather some information regarding to receiving requests from outside. Maybe I need to add some detail to the metrics, and further on I can just analyze based on this metric that can be collected and shown on dashboard. Data quality is a critical aspect of an effective observability strategy. To maintain the quality of collected data, data sources from various monitoring systems should be standardized to prevent redundancy, reduce clutter, and minimize noise. Therefore, regular audits helps you maintain a streamlined and efficient observability system, such as deleting unused dashboards, alerts, or logging entries. When it comes to visualization and dashboard, there are some components that needs to be taken care, like graphs and charts. With the help of charts, we can just represent in an easy way to display trends and patterns over time, like by utilizing line charts, any type of other charts that we have. And visualizing means visualizing the metrics like response time, error rates, or resource utilization through graphs. And it makes it easier to understand and gain some insight from the metrics that we have collected. The second one is customizable dashboard. Customization ensures that the different team members can focus on the insight that most relevant to their team. And the last one is real-time monitoring. Most of the dashboards actually often support real-time update providing live monitoring capabilities. It means in most of the places we need to monitor real-time performance of the application. So based on these metrics, we can choose a proper tool that can help us to visualize our metrics. One of the best options that we have is Grafana. Grafana actually is an open source platform supporting a variety of data sources with extensive visualization options. It also supports real-time monitoring, customizable dashboard, and graphs and charts. The second option is Kibana. Paired with the Elastic Stack, Kibana excels in logs and event data visualization. In case you want to collect your logs in one place and centralize your logs, Kibana can be best option for visualizing your logs. And in case you want to perform some query on your logs, it would be much easier with the help of Kibana. And the next one is Dynatrace, which is known for its comprehensive observability platform. With the help of AI, you can just detect any type of unexpected pattern in your application behavior, and it provides different type of dashboard that you can customize based on your requirement. Of course, it supports real-time monitoring and graphs. Now let's talk about the frameworks that we already have for data collection. When we are talking about data collection, means we want to gather some metrics from our application in order to analyze and to monitor behavior of the application. There are so many options out there, but I have listed some of the best here, like OpenTelemetry, Zipkin, Prometheus, and New Relic. These frameworks actually are used to instrument code, capture telemetry, and enable monitoring, tracing, and logging. With the help of these frameworks, you will be able to expose some metrics from your application. Now let's see Prometheus behind the scene how it works. In the central part of Prometheus server, we have three main components: Retrieval, TSDB, and HTTP server. And as you can see, there is a connection between TSDB and storage, which can be hosted on a different nodes, and your Prometheus server can be hosted on a different one. So we can persist all the metrics that we have collected in this storage. And of course, it should be a time series database, and Prometheus already provide this type of database for us, and we can easily use it. When we talk about retrieval, means we will be able to discover different type of targets in case your application hosted on a Kubernetes. With the help of service discovery, you will find your targets which needs to be monitored. Now with the help of retrieval component, we can pull metrics from different type of targets that we have. Let's say it can be any type of application that you have hosted on Kubernetes, or in the other side, we also have some short-lived jobs that they are not able to expose metrics. So with the help of push gateway that is also part of Prometheus, we can gather metrics and persist it in databases. Next component is Alert Manager. With the help of this component, we will be able to notify different parts of the system based on the receiving metrics. Let's say we are receiving some logs from live environment which the log level is error. So in that case, we can set some criteria to notify ServiceNow, which is an incident management tool, or we can send some email, or even we can send some notification to Microsoft Teams or Slack. And the last part here, we can expose our metric through HTTP server to outside with the help of Prometheus query language. Here you can see Prometheus itself has some UI in case you want to show your metrics in the UI part, or even you can connect your Grafana endpoint to Prometheus server, and with the help of query language you can easily query your specific metrics from Prometheus server. Also, you can expose your metrics to outside to any other API client that you want. The other framework is OpenTelemetry. OpenTelemetry actually is an open source project that provides a set of APIs, libraries, agent, and instrumentation to enable observability in application. Also, it supports multiple programming languages, so it doesn't matter if you are coding in Java, C# or any other language. There are so many SDKs and libraries that you can use OpenTelemetry to scrape and expose your metrics to outside. Here we can see the diagram how OpenTelemetry works behind the scene. And developers use OpenTelemetry instrumentation library to add code to their application that captures traces like request flow or metrics such as performance indicators. These traces and metrics are then sent to observability platforms like Jaeger, Prometheus, Dynatrace. And you can see in this diagram Telemetry is platform agnostic, means you can scrape and collect your metrics in a standard way and expose it to any type of platform that you have. Now let's talk about incident automation and how it's gonna fit in observability. Generally, when we are talking about incident automation, it means we should automate processes and workflows to respond and resolve any issues detected through monitoring, logging, or tracing. Let's say I have an observability platform that detects some kind of unexpected pattern in the system. So based on the workflow that we have already defined for that, maybe we can resolve this problem without any intervention. And in that case, we can minimize downtime and enhance the overall reliability of the software system. There are so many incident automation tools out there, but ServiceNow and PagerDuty are one of the best that I have known. For example, ServiceNow enables you to build workflow for incident resolution based on the observability data, and it can easily integrate with your observability platform. For example, in case of any incident, we can create automate task for that, notify some teams that they are responsible for checking and monitoring the status of the system. Now imagine a scenario where an e-commerce application experiences a sudden surge in response times due to the increase in user traffic. This issue is detected through observability tools. So first step is gonna be detection. The monitoring system identifies a significant increase in response time, triggering an alert. Afterward, alerting comes to the picture. PagerDuty receives the alert and follows an incident response playback that includes automated steps. It means we already have defined some steps in case of any type of incident. So PagerDuty can follow the steps and create some kind of response for that. Now it's time to automated response, which involves scaling up the application server instance in the cloud to handle the increase in the load. Now it's time to verification. The system continues to monitor the performance of the application. If response times returns to normal and other key metrics stabilize, the incident is considered resolved. And at the last, we have notification step, means PagerDuty or ServiceNow sends notification to the on-call team, informing them of an incident and the automated resolution. In this scenario, incident automation and remediation helped address an issue swiftly, ensuring optimal user experience and minimizing the impact on the other part of the system. Like any tool or service or practice, it comes with its own set of challenges and pitfalls. Here are some common challenges and pitfalls in observability. First one is overwhelming amount of data. Imagine a system that generates a massive number of logs and metrics per second. Without proper filtering and aggregation, it becomes challenging to pinpoint the root cause of an issue. The second one is lack of standardization. If one microservice uses a different naming convention for logs or metrics than other, it becomes harder to correlate data and understand the end-to-end flow of a request. So it's better to define a convention between your teams if you are working on a big system and with a lot of services. The next one is alert fatigue. If every minor anomaly triggers an alert, it can lead to a flood of notification that may not necessarily indicate critical issues. Another one is incomplete instrumentation. If certain critical code paths are not instrumented for tracing, it becomes challenging to follow the flow of a request through the entire system, especially in a distributed system. And the other concern is privacy and security concerns. Logging may inadvertently capture personally identifiable information or PII without proper precautions. This could lead to compliance issues and compromise user privacy. Another one is complexity in distributed systems. Identifying the root cause of a performance issue might involve tracing a request through multiple services, each with its own set of logs and metrics. Without proper tools and practices, this complexity can lead to longer resolution time. And the last one is skill and training gaps. If team members are unfamiliar with the query language of a logging or monitoring tool, they may struggle to extract meaningful insights from the available data. So whenever you want to choose some observability framework, just take it into consideration the team members' skill level and training gap. Here is the list of challenges that we are facing when we are adopting any type of observability platform, specifically when we are working in a big and complex system. But we can also add so many other options here like cost management. Last but not least is choosing observability tools. When it comes to choosing a tool, you need to be able to benchmark them based on different aspects. But in observability, we have so many options. I have listed some of the best here. Of course, we have so many others like Dynatrace, Prometheus, Grafana, Azure, Google, AWS, Datadog, ELK, Splunk, and Samologic. We have so many open source projects, we have non-open source project, and based on your requirement you can choose one of these options. But for example, Dynatrace and Datadog, they are enterprise services. They are also able to integrate with different cloud. Just by putting some agent on the cloud, you can collect any type of metrics you want. But in case you're working on a small application or a small service, maybe you don't need to adopt any enterprise service. Just using some open source like Prometheus is enough for you. Just take it into consideration. Final thought: in summary, adopting effective observability and monitoring is crucial for successful software development. Real-time insights enable swift issue resolution and enhance overall application reliability. Thanks for watching. I'm Matt Gafuri from Code Boulevard. Hope you enjoyed it.